Hello and welcome to this online FMSP revision session. This session is looking at the MEI D2 specification and the topic is linear programming the Simplex method. So we'll start by having a look at the specification. First of all, you have to be able to solve simple maximization problems with less than or equal to constraints and 2 or more variables. In reality, it won't be more than 3 variables. Then you have to be able to identify various stages of the tableau, so initial, intermediate and final tableaus with the feasible points, and particularly that's the case involving 2 or 3 variables. And you have to be able to set up and explain an initial tableau. Then progressing on from there, you have to know and be able to apply the two-stage simplex and the big M method to construct an initial feasible solution to a problem involving greater than or equal to constraints, and to understand how to model equality constraints using a pair of inequality constraints, or that is how you would do it. You're unlikely to be asked to do this in reality, though you may be asked how to solve that type of problem. So let's look at some examples. First of all, we've got this one. This is the whole problem. As you can see, in common with a lot of decision maths problems, there's a lot of words to read on here. So it's a good idea to take it one step at a time. So part 1 says that there are 3 chemical products, X, Y and Z, that are going to be made. And then you have a lot of information. And the first part of the question is explain how the initial feasible tableau shown in figure 4, which is this diagram here, models this problem. So in other words, they are giving you the initial tableau, but they want you to explain how they got that initial tableau. So the first thing you always do when setting up a linear programming problem is define your variables. And in this case, you can see that they've used little x, little y and little z. So we're going to say let little x be, and then you have to think very carefully about what it is. Little x is going to be the number of litres of product X produced. Don't be tempted to write little x is big X, because you won't get any marks for it. You've got to be very specific. So little x be the litres of X produced. And then similarly, Y is the litres of product Y that produced, and Z is litres of product Z that's produced. And it's fine to write it like that. You don't need to write long sentences, but you must be clear about what you mean. Then we've got a top row here which represents our objective function, and that in this particular case is going to be the profit that we make. So our objective is profit, and we have to explain how we got this objective. So if we look minus 10, minus 10, minus 20, and we look up here about what it says, and it tells us that product X sells for 40 pence and costs 30 pence a litre to produce. So our profit is going to be 40 pence that it sells for minus the 30 pence that it costs to produce. Similarly for Y, we've got 40 and 30. And for Z, we've got 40 and 20. So simplifying that gives us P is 10x plus 10y plus 20z. And of course, when we put that into the tableau, we would be rearranging that so that we would have P minus 10x minus 10y minus 20z is equal to 0. And then finally, we've got 3 constraints here. And those constraints will be from the rest of the information in the question. Now, they never give you redundant information in these questions. The information given should all be used. So sometimes it's useful to tick off the information that you've used as you go and make sure that you're not reusing information, but that you've used everything that they've told you. So let's have a look at our constraints now in more detail, and what we can see is that we've got 3 additives that are used to produce the products. Product X uses 5 grams per litre of additive A, 2 grams per litre of additive B, and 8 grams per litre of additive C. And I should say that that is an error on the question there, and that was corrected, and it should be grams and not kilograms. And you could probably have arranged that yourself. Sorry, that kilogram stays. You could have guessed that yourself from the context of the question. So we have here 3 additives, and we're going to have a constraint relating to each one. So additive A, product X uses 5 grams per litre. Product Y uses 2 grams per litre, and product Z uses 10 grams per litre. And that can't exceed the amount of additive A available, which was 12 kilograms. So that has to be less than 12,000 grams, and be careful to keep your units the same. Then for additive B, X uses 2 grams, Y uses 4 grams, and Z uses 5 grams, and that can't exceed, sorry, A should have been 10 and this should be 12 kilograms. I apologise, I didn't read correctly. And C is 8 grams of X, 3 grams of Y, and 5 grams of Z, and that can't be greater than 8 kilograms, so that's 8,000. And of course, when we rearrange those for the Tableau, then we will add slack variables to make them into equalities. So for A, we will have 5x plus 2y plus 10z plus S1 is equal to 10,000. For B, our constraint again, plus S2 is equals to 12,000. And for C, it's going to be 8x plus 3y plus 5z plus S3 is equal to 8,000. And that's explaining what we've done in the Tableau there. There are 6 marks for this part of the question. And then the question goes on and asks us to use the Simplex algorithm to solve the linear program and interpret our solution. So it's a straightforward Simplex. We'll use the algorithm to do it. This is the initial Tableau set up, and the algorithm says first of all that we have to find a pivot element, and we're not told in this particular question what to pivot on. So the convention is that we pivot on the most negative entry in the objective row, which is Z there, and we then perform the ratio test to decide which element in Z we will deal with. And the ratio test takes the right hand side and divides it by the coefficient of Z. So 10,000 divided by 10, which gives us 1,000. 12,000 divided by 5 will give us 2,400. And finally 8,000 divided by 5 again, which gives us 1,600. And the smallest of those is our 1,000 here, so our pivot element is going to be the 10 there. Now it's a really good idea as you're doing this to label your rows. So you'll see I've labelled them 1, 2, 3, 4. And then to continue to label the rows and to say what you have done each time. It's not essential, but it helps the examiner to see what you've done and helps them to work out what's happened if something's gone wrong and you've made a mistake. So first of all, what we're going to do is we're going to take the row that contains our pivot element and we're going to make this coefficient 1, and we would do that by dividing row 2 by 10. So this one will be row 5, row 6, row 7 and row 8, and row 6 is the old row 2 divided by 10. And if I do that, then I'm going to get 0, 0.5, 0.2, 1, 0.1, 0, 0 and 1,000. Now I know sometimes these are worked out using fractions, and if they're nice easy fractions you're very welcome to use fractions, but it isn't compulsory. It's absolutely fine in the examination to use your calculator and do decimal answers, so whichever is more straightforward for you. Right, once we've got a 1 in our pivot row for our pivot element, then we want to get zeros in this row so that we make this row a basic in this column, so that we make the column a column of basic variables. Z will be basic. So we need to work out how many of this number 1 we need to add or subtract to our rows up here in order to get zeros in the Z column. So we're going to start by saying row 5 is going to be row 1 plus 20 times row 6, and it's always easier to work from the row that you've just reduced to a 1, because obviously you're not having to do such nasty calculations. So doing that is going to give us a 1 still here, because that won't matter. 20.5 is 10, so that's going to become a 0. Here we're going to have a negative 6. Here obviously we're going to have a 0 because that's how we decided it. This will be a 2, and those will stay as zeros. And our profit has now become 20,000. So the profit's gone up, which is as it should be, from 0 to 20,000. To get row 7 here, then we're going to take our old row 3 and we're going to subtract 5 lots of row 6, and that will give us this. And finally, to get our row 8, we're going to take our old row 4, and again we're going to subtract 5 lots of row 6, giving us so there we are, that's the end of our first iteration. And I think on the next slide I've done a tidy version, just in case I made any errors or my writing wasn't legible on the previous one. And we can see immediately that this is not optimal because we still have a negative value in the objective row, and the optimal solution is reached when we have no negatives left in the objective. So now we're going to pivot on Y, and you'll see that I've already done the ratio test here, and you can see from that ratio test that the smallest ratio is 545.45, which is there. So this now becomes our pivot element. And we'd repeat the whole process again, so I'm not going to go through it in immense detail again. This is what it would look like. Divide row 8 by 2 to give us row 12, and that gives us a 1 here. And then we are going to take away multiples of row 12, or add multiples of row 12 to get zeros in that Y column there. And once we've completed that, we have a look again, and you can see here that the top row, the objective row, is all positive. So that means we've got the optimal solution. So all that remains for us to do now is to interpret that solution as the question asked us to do. So there's our solution. What can we read from this? Well, for a start off, the profit is 29,000, and I think you'll find that was in pennies. So probably a good idea to write that in pounds. And then looking at what the values of all the variables are. The ones that have ones and zeros in, the X and the Y, and the slack 2 as well, interestingly, are what we call basic variables, and they're the ones for which we have solutions. Where you have columns like the X column and the S1 and the S3 columns where there's a load of numbers, then the only way that you can make this solution work is for those variables to be equal to 0. The reasons why are complicated, so at this close to the exams, just trust me. So reading off the Tableau, we've got X must be equal to 0. We've got Y equal to 1,500. And these were in grams. We've got Z is equal to 700. So in terms of our interpretation, we can say make 1,500 grams of product Y and 700 grams of product Z, giving a profit of £290. And it's very important that you write that solution out, that you don't just leave it like this, because you will lose marks. You have to actually properly interpret the solution in the context of the original problem. Now, you weren't asked for it here, but you could be asked for the values of the slack variables. And if you were, then you can do that from the Tableau as well. You can look up here and you can say, well, S1 is a load of numbers, so S1 must be equal to 0. S3 is also a load of numbers, so S3 is equal to 0. But S2 has a value, and S2 is 2,500. And what that tells us, if you are asked to do it, is that there is some surplus capacity on additive B, which was the additive that S2 was associated with. So we can say there is 2,500 grams of additive B left over. And as I say, you weren't asked for it here, but you could be asked for that. What you were asked for here is this. The optimal solution involves making 2 of the 3 products, so well done us, we've found that. By how much would the cost of making the 3rd product have to fall to make it worth producing, assuming selling prices don't change? So we look at the 3rd product, which is X. And we can see that up here there's a value of 16.5 left in the objective row. So if X were 16.5 pence cheaper, there would have been a 0 in the objective row, and we would have had X as a basic variable. So we can say for the answer to this is that we want to reduce the price of product X by 16.5 pence. And that's all that's required. You don't need much. You can see that it's 1 mark, and wherever you have 1 mark, it's something that is very straightforward, or something you're expected to be able to just read off the paper. So no working or explanation required. Looking at the mark scheme here, you can see 1 mark up here for defining your variables, and you'll notice it specifies in the mark scheme number of litres of X. There's 2 marks for getting the objective correct, and in this particular case they've divided it up M1, A1. So M1 is for realising that the profit is the selling price minus the cost, and then A1 is for getting it all correct. There's 3 marks for the constraints, so again they've divided it up M1, A2, and the M1 is for getting a constraint right, and then the 2 there are for getting the other 2 correct. You didn't need to write them out with slack variables. I did because it explained the process to you, but they're quite happy for you to leave them like that as long as you understand that that's how they've gone into the Tableau down here. And then on the Tableau you had to do 2 iterations of the Tableau, so there was 3 marks for each iteration. 1 mark for getting the pivot correct, and then a method and an accuracy for the working in both cases. And finally, a mark for stating litres of the product, a mark for the profit, and a mark for the 16.5 pence per litre reduction in price. Then the question goes on. There is a contractual requirement to provide at least 500 litres of product X. Show how to incorporate this constraint into an initial Tableau ready for an application of 2-stage Simplex. Describe briefly how the method works. You are not required to perform the iterations. So what we're doing here is making the question a little more complex. They're saying we've got a new constraint, and that new constraint says at least 500 litres of product X, the one that we didn't make. So 5x has to be greater than or equal to 500 is our new constraint. When we have greater than constraints, what we have to do is we have to incorporate a surplus variable and an artificial variable. So it becomes X. And instead of adding a slack, what we do is we subtract a surplus, and it will be S4. And then we add an artificial variable to make it an equality. So there is our new constraint. And we also have a new objective. And our new objective is the thing that is formed from the sum of the artificial variables. So in this case we only have one, A, so Q is going to be equal to A. And the idea of this is that the A tells us that we are not in the feasible region when we've got to minimize, when we've got a greater than constraint, we have to move ourselves up so that we are greater than first. And so we're going to start by minimizing Q till A is equal to 0, and we know we're in the feasible region. So looking at this, we can say that A is going to be equal to, and it's going to be 500 minus X plus S4. So that's going to give us Q is equal to 500 minus X plus S4, or Q plus X minus S4 is equal to 500, and that's what it will look like when it goes into the Tableau. So this is what the Tableau would be set up as, and the method that we would need to use is we would minimize Q till it is 0, and then after that we would proceed as normal. And that's why it's called a two-stage simplex or a two-phase simplex, because there are two distinct things you have to do. First of all, to minimize Q, and then to maximize what's left once you've got Q equal to 0. This is what the mark scheme had. It put it in a Tableau. I haven't put it in a Tableau. It doesn't matter whether you put it in a Tableau or not, as long as we can see this, but most people choose to put it into the Tableau because it helps you. 1 mark for getting the new objective correct, the Q. 1 mark for getting the surplus and the artificial values correct, and 1 mark for completing the new constraint. So there's our constraint, there's a mark for that. There's a mark for the objective up here, and this mark here is for being able to see the S4 and the A correctly. And 2 marks there, 1 for minimizing Q and 1 for proceeding as normal. The examiners, before I mention the examiner's comments, I should just mention the big M method. Some people choose to do this. It is never specified. I have seen two-phase specified. I've never seen big M specified. It is an alternative that you may use if you wish, but you don't have to. But I'll just quickly run you through. We add the additional constraint as normal, and then we modify our original objective by introducing this large number M, which is the sum of all the artificial variables, and subtracting it from the objective function if you're maximizing. So the objective for this one will become P is equal to 10x plus 10y plus 20z minus MEI. And of course we know what A is from before. A was 500 minus x plus S4. And when we tidy that up, we're going to have something that looks a little different. And rearranging it is going to give all of this stuff here on the same side as P. So putting that into the Tableau, it would look like that. And that's a perfectly acceptable alternative. In this particular case, what you would do is you would solve as normal, pivoting on x initially, because if m is a very large number, then minus m plus 10 is definitely going to be the most negative. And what you will find is that the right hand side, the m disappears and it all tumbles out if you do it correctly. So our examiner's comments. First of all, candidates have been well prepared for this question. Some were able to romp through it faultlessly. I like the wording there. General standard was good, so people do well on simplex problems. They learn their stuff and they do well. the first mark, which hardly anyone registered, that is defining the variables correctly. And it says that specifically here. A lot of people didn't get the reduce the price by 16.5 pence, and apart from those 2 marks, they all scored well, with just a few people not being able to set up the 2-stage simplex at the end. This is another question, very similar, as these questions always are. And you can see that it's pretty much the same layout, slightly less words here, or fewer words. So it starts off with formulate the linear programming problem. So you weren't given anything this time, you were just asked to formulate. So it's the same procedure. I'm going to call my variables A, B and C this time. And A is going to be the tons of product A. And I know I keep batting on about it, but it is really important that you get those. Our objective function, what are we trying to do here? Well, we are trying to maximize production. So P in this case would be equal to production, and the production is the amount produced, so it's going to be just maximize the number of tons produced in total. And then the constraints, and again we look up here, we've got something about tons of water, and we've got something about labour per ton. So there's going to be 2 constraints in this case, a water constraint, which is 3a plus 2b plus 5c less than or equal to 60, and I've used the 3 there, the 2 there, the 5 and the 60. And we've got a labour constraint, and our labour constraint in this case, our time constraint if you like, is going to be 5a plus 6b plus 2c less than or equal to 150. And that's using, less than or equal to 50 even. Apologies. That's just using the information that is given to you in the question. Use the simplex algorithm to solve the problem, pivoting on the column relating to product C. So this time you were told to pivot on column here, and we've only got 2 constraints, so it's not so bad. I'm starting off by merrily labelling my rows so I don't forget to do it. Pivoting on C, our ratio test is going to be 60 over 5 and 50 over 2. So we will use this as our pivot element because that's the smaller one. So our 5th row is going to be row 2 divided by 5. And the reason I selected this one is because it actually has some quite nasty numbers in it. And again, I'm using decimals here. And then to get row 4, we're going to take row 1 and add our new row 5 because it was 1 and minus 1. And to get row 6, we will take our row 3 and we will subtract 2 lots of row 5. And you can see that already we've got some 3.8s and some 5.2s and things cropping up. After one iteration. Now looking at that, we've got two negative entries in the top row, and the entry in column B is the most negative, so we will pivot on column B. Doing the ratio test again, that's going to be 12 divided by 0.4, and this one is going to be 26 divided by 5.2. And if anybody thinks I'm doing this quickly in my head, I should reassure you that I used a calculator to do it earlier. So I'm not pretending to be a super person here. There it is. That's our pivot element. So row 9 is going to be our old row 6 divided by 5.2. And this is where things start to get nasty. So if you work these out in a calculator, you don't tend to get nice answers like 0.73. You're going to get a lot of decimal places, and it's not that important, to be honest with you. In this particular case, what we are interested in is getting these basic variables correct. So a couple of decimal places worked out on the calculator is fine. Row 8 is going to be our old row 5, and then we're going to have to subtract 0.4 lots of row 9. So, and our row 7 is going to be our old row 4, and we're going to add 0.6 lots of row 9. So you can see that it's actually a deceptively horrible question. And I will show you something in a moment that should make you feel a little bit better about that. Around about here, I'm losing the will to live. So I got to these numbers here and they were horrible. And I'm just going to leave them. I'm not going to bother with them because they are not relevant to the solution. And whilst it's really important that you put down everything you need to put down, in the case of this particular question, you will see that on the mark scheme, none of these numbers have actually been filled in. They've been filled in with greater than 0 on the top row so that we can say that the solution is optimal. So where I filled them in here, that was fine. But I didn't actually need to. I just needed to ascertain that they were greater than 0, which they were. And if they're all positive, it's optimal. And then down here, we didn't bother at all. So no marks for getting all those fiddly little numbers. Don't worry too much about them. Looking at the mark scheme again, we've got 3 marks for setup. This time we've only got 2 marks for each. So we've got 1 for setting up the initial Tableau and 2 marks for each iteration. It's not a lot really. And 1 mark at the end for the interpretation, which I didn't write in here because I didn't have room, but you can see that we've got no A. We've got 5 B and we've got 10 C. So 5 tons of product B and 10 tons of product C was the interpretation. Again, it goes on to add an extra constraint to supply at least 8 tons of product A. And we're this time being asked to solve the revised problem, which is a little bit nasty. We know that A has to be greater than or equal to 8. So in other words, A minus S3 plus, now because I used A, B and C, I shouldn't really have used an A there, so I've used an R. And that's my additional constraint, which I'm going to put down at the bottom. Otherwise, the surplus and the artificial have zeros in them. And then my new objective, Q, is going to be equal to A, which is going to be 8 plus S3 minus R. So we've got Q minus S3 plus R is equal to 8. And all these are going to be 0. So I've set up my initial Tableau. I then have to solve it, so the first thing we need to do is minimize Q. And rather than spend a lot of time writing out, here's one we did earlier. So minimizing Q is going to give us pivot on the most positive. So we're minimizing and in fact the only thing we can pivot on here is A, and it's 1 already. So in that column, so we perform the ratio test and we get the pivot element to be down here, which is again 1. So we just need to carry that row across and then perform as before multiples of that row added and subtracted to get zeros in every other entry down there. And what you find at the end of that process, as long as you pivot on the most positive entry, because that's what the minimization says, is that we've actually now reduced the value of Q to 0. And once we've done that, we are inside our feasible region. So then what we can do next is we can actually get rid of the Q row, the Q column, and we can also forget about the artificial and just have the Tableau in the middle here and proceed as normal with that Tableau. So in this particular case we've got negative entries at B and C, and they are both -1. We've also got S3 there. So we've pivoted on C in this particular case, and after one pivot you can see that you have an optimal solution. So I haven't gone through that in great detail, but just to show you how the process works and that it's very much the same as a normal simplex. It's all in setting it up correctly in the first place. And there's the answer. So a mark for the new constraint there, a mark for surplus and artificial values, and a mark for the, 2 marks for those, this time generous, a mark for getting the new objective, 2 marks for the first iteration, and then 1 mark at the end for the final iteration, and 1 mark for writing the answer out. Examiner's comments again. Again, it says that people were very good in basic simplex. Not identifying and defining variables, that was a problem again. So it continues to be a problem year on year, this one. And there's a lot there about writing number of and so forth. And similarly, interpreting your results correctly. So not just writing down B equals 5, C equals 10, but actually interpreting properly. So those are the key points to take away. That is the end of this session. Good luck with the exams, and I hope that it all goes well for you and that you do brilliantly on the simplex question.